properties of logarithms. So this is definitely a continuation of what we were doing last week. In fact, I feel like we talked about some of these rules. If we've got the log of a product, that can be expanded into log of the first plus log of the second. Then we've got our quotient property. If we've got log of a quotient, that can be expanded. Log of the first minus log of the second. And then I know we talked about this. This little power property, that guy can move down in front. Now, depending on the problem you guys are focusing on, it will either ask you to expand it or to simplify it and make it as small as possible. So just always look for what they're asking. And then we have our change of base formula. How many of you have figured out how to do the change of base in your calculators? We talked about that last week, if I remember right, didn't we? Should we remember where that is? I need to remember where that is. This guy? Oh yeah, there it is. So it's just that button right there. So remember, when you use the LOG button, it's always base what? Always base 10, because our number system is base 10. So watch, if they give you a different base and they want you to calculate it, you guys are welcome to use that button, or this is the old school way. You just make a little division problem and you'll get the same answer. Also, we'll be doing a lot of moving, I think, from logarithm form to exponential form. So let's remember, if we've got log base b of x equals y, and that's logarithm form, what does exponential form look like? Good. B to the y equals x. Yep. All right. So a lot of solving today, if I remember right. If you ever have one logarithm, like we do in this problem, you're usually stuck unless you put it in exponential form. So I see one logarithm, nothing to simplify, so I'm going to put it in exponential form. 36 raised to the 1/2 equals x. And all of a sudden this feels comfortable and familiar. This just means the square root of 36, which is 6. Simplify your answer as much as, that feels pretty simplified. Basic properties of logarithms. Fill in the missing values to make the equations true. All right, chances are, if we see a minus, what are we going to rewrite it as? A division problem. And it's always the first one divided by the second one. So this is going to be 9/2. And if we've got an addition, chances are it was multiplication. So 3 times what is 15? 5. Ooh, and what do they want on this one? Tell me why. So you did a little reasoning there. You said if I did 5 raised to the -2, how do I fix a negative exponent? So that's just 1/5 squared, which is 1/25. So remember, negative exponents give you fractions. All right. Use the properties of logarithms to evaluate each of the following expressions. What do they want me to do?
I'm on the homework right now. They want you to find the numbers, so the 8 ln e2 minus ln e5 would be just a second.
So can I put this down in front?
Yeah.
2 times? Can I put this down in front? So then, ln of e, you guys, let's remember how this works. ln, yes sir. So yeah, that's what we're going to talk about right now. We never see it this way, but this is logarithm AC of e. How many e's are in e? 1. So this, it essentially cancels out, right? So then if I've got this ln of e and this ln of e, now I've got 16 minus 5, which is 11. Whoops, that's almost off the screen. Sorry about that.
So the 2 ln of e's cancel.
ln of e, if it's only an out, like see how we had to move that exponent first?
Yeah.
If you see ln of e, they are inverse operations essentially of each other and they equal 1, so they cancel each other out. On this one, we have the same base, we don't have any exponents, but I have an addition. So I can smash this into one logarithm with what operation? Multiplication. So 2 times 18. So now I've got log base 6 of 2 times 18 is 36. 6 to the what is 36? Yeah, so this equals 2. So we were making things smaller. And in the next problem, they want us to expand everything. And you'll think you're done, and sometimes there's one more step. So just make sure it's completely expanded. What is happening, what operation between x to the 6th and z? Times. Yes, so we're going to expand it using add. Absolutely. So I'll write it down here. We're going to have log of x to the 6th plus log of z. I was saying I'll type that in, and I've got it wrong because what, Spencer? That's another thing we can do to expand it. That 6 can go in front. Log base x plus log of z. And those will all be different, so if you get stuck, holler at me. And then this one is all expanded, and we're supposed to what? Yeah, make it as small as possible. And this is kind of like, remember when we were doing direct joint variation and you watched in order if we were multiplying or dividing? It's kind of similar stuff here. Before we can do anything, you can't have coefficients. Those all need to be rewritten as exponents. I'm going to clean that up. That's pretty ugly. Log a w to the 1/3 plus log a z to the 7th. All right, we've got a minus and we have a plus. We know the minus means division. We know the plus means multiplication. There are a couple different ways you can do this. I'm going to start by doing this first. We can smash it. And division, so I'd have x to the 6th divided by w to the 1/3. And then now that I have to add, what does this look like when I multiply those together?
Log a x z to the 13. Oh, wait.
Oh, you wanted to add those.
Yeah.
We don't because they're not the same base, right?
Yeah.
Yeah, I can see where you're going.
and then W1 is C7.
Is on the bottom.
Wait, where did you get log base
Oh.
6?
Did I rewrite it? It's supposed to be me.
Oh, okay.
Thank you, that's a good save. Okay, this says to use the change of base formula. I just want to show you how friendly it is. This is log of 1/7 divided by log of 5. That's all it is. So you can type it into your calculator, log base 5 of 1/7, or I'm going to choose to do it this way just to show you I can. Whoa, get out of there. Log of 1/7, and we're going to divide that by log of 5. And I get negative 1.209 round to the nearest thousandth.
So is it just the log one without the base?
So you'd be looking right here.
Okay.
And let's make sure I did that right then, I guess. 5.
Yep.
Arrow over. I did do it right. You already figured it out. There it is. The exact same answer that we got a second ago.
Okay.
I'm glad you asked and made me do it. Yeah, so our white calculators, that button right here.
So you just plug it in.
Yep, and you just plug it in and hit enter. But I did want you to see how friendly that change of base formula is. We'll cover that as we go. How's that? Oh, this is such a friendlier lesson than what we've been doing. Let's go through this. Solve for x. All right, on this one, what is the first thing you'd want to do? Curious. I could make it an exponent and make this an uglier problem. Or, I love that you're seeing that you can do that. Can I do that since there's not a logarithm on the other side? So then I have ln of 3x, the natural log of 3x equals 2. And all of a sudden now I don't have an x squared that I have to solve for, which is nice, right? Hey, do you remember what numbers we can't take the logarithm of and that we've always got to check our solutions? Can I take the log of 0?
No.
No. Can I take the log of negative numbers?
No.
Okay, I know you guys told me there's negative in here somewhere.
Oh, yeah, you can. Wait.
I cannot take the log of a negative or of 0. So we always need to check our solutions.
So does that mean you can't have a log to the bottom of negative?
Oh, that's when we were raising to an exponent, and our exponent was negative. I'll show you what I mean right now.
Okay.
Okay, let's solve this one and we'll look at it. Okay, I need to get rid of the natural log. When we have one logarithm, we said we were stuck. So what do we do? What's my base? E. E raised to the?
Second divided by 3.
Good. So E raised to the second equals 3x. Britton already did this for us. He says that's going to be our next step. All right, where is the E button on this thing? I've got to do the second, don't I?
don't know if you...
Yeah.
That one right there? All right, let's get out of here. So second E to the second?
Yeah.
Second. And then I'm going to divide that by 3. Round, do not round until the end. Round to the nearest hundredth, 2.46. So, Reese, to follow up with your question, sorry about that, guys. I I'm going to check my solution right here. I'm going to take this number and I'm going to plug it back into my equation. I can even come back to the original. Is 3 times 2 point, whatever that is, a positive number? Yes. So that means it's a good solution. If I had, in this case, ended up with a negative answer doesn't mean it's bad. But plugging it in 3 times that negative number, if I end up getting a negative number, that's what makes it a bad solution. Did that complete that circle for you a little bit? Okay, we'll keep working on it. Ooh, what about this one?
Gross.
Gross. Well, go ahead.
Wouldn't it be 2 log 2 over log 2? Like, are you putting it in the,
This one right here?
yeah, the first, the x minus 2? Like, I mean, both of them, isn't it 2 log 2 over log 2 less 6 log 13?
He's manipulating it in his head. Should we get there together?
Yes.
All right, let's get there together. If these, I think you're right. We're going to see. So if these, like if this was a 4 raised to the negative 6x, could we rewrite this and solve using exponent properties? Yes. But did 2 and 13 have a common base? No. And my variable is in the exponent. So this is when we use logarithms to get those exponents back on the ground. You can use log or you can use ln. Either one, pick your favorite. You want to know why this one is my favorite? It's faster for me to write. That's why I go with ln. That is legit the only reason I choose ln over log. It's an extra letter if I go the other way.
Are they the same thing?
They are not the same thing, but when I'm doing the same operation on both sides of the equation, we will get the same answer. We will get the same answer. So I want to remind my brain that x minus 2 goes together. Because what are we going to do with those exponents? I can now move them into the front. So I have got x minus 2 times ln of 2 equals negative 6x times ln of 13. This is one of those problems that has a little algebra sneak in it. So I just want to point it out. And this is where Britton was. He says, okay, the exponent's just going to go on front. But then I know that I'm going to distribute it, right? Isn't that what you were saying to us? So I've got x ln of 2 minus 2 ln of 2 equals negative 6x ln of 13. Now, I've got this problem because I have a variable here and here, and those are not like terms. So your sneak is to get those both on one side of the equation. I'm going to choose to move this over here just because I want it positive. X ln of 2 plus 6x ln of 13, which means I'm going to move this one to the other side. 2 natural log of 2. Questions with how I got there? All right, does anybody know the algebra trick we're going to use right now to help us solve for x? We're going to factor it out. Yep, we're going to factor it out. So then I have ln of 2 plus 6 ln of 13 equals 2 ln of 2. What do I need to do to solve for x now? Divide by that big ln of 2 plus 6 ln of 13. Oh, it wants to the nearest thousandth. This is when we miss our yellow calculators, right? Where we can just type it all in. All right, so if I want, I can do it. 2 ln of 2. And then we're going to have ln of 2 plus 6 ln of 13. Uh-oh. What don't I have? I'm not going to be able to insert that in my... Oh, it did let me. And I get to the nearest thousandth would be 0.086. Do you guys remember doing those last year? Did you have a question, Reese?
Yes.
Ready, set.
Would you be able to do on the bottom 6 ln 26?
6 ln, so this would have to become a 13 raised to the 6th power first.
Okay.
And then you could.
But you could technically combine them.
Because of the addition? Absolutely. Absolutely. That's a good question. Okay, story problems. I think the biggest thing on these is it says doubles or triples or halves, and we just have to remember what that looks like. We are talking about continuous exponential growth or decay. So our formula is y, and then we've got y sub naught, y in the beginning, e raised to the kt, where k is your rate and t is your time. This is the initial value, and this is the amount after time. You guys are labeling those, so I'll put them in. Rate, time. Okay, on this one, it says the mass of a radioactive substance follows a continuous exponential decay model with a decay rate parameter of 0.78%. So what is my K? If we are decaying at 7.8%. You're right.
Oh, okay.
Negative. And then it says find the half-life of the substance. So T is what we're looking for. We don't know. That is the time it takes for 1/2 of the original amount it is given. That's all it gives me. So if I'm going to solve an equation, I can only have one unknown, right? So if I'm told I'm solving for time, that means I should be able to figure out y after time and the initial amount. Any ideas? All right. If I have 10 grams, let's say, don't I have all of the 10 grams? I have 100% of the 10 grams. What if I have 1,500 grams? Don't I have all of the grams? 100% of the grams? Okay, so how many of those grams would be left after the time passes if it's half-life? Half of them, right? So could I say in the beginning, whoops, wrong one. In the beginning we had 100%. We had 100% of however much it was. And after time, because it's half-life, how much do we have left? 50%. So we're just going to use 0.5 and 1. That's the big sneak on these problems, okay? So now I'm going to plug that in. After time, in the beginning, e raised to the negative 0.078, and we're solving for t.
But how did you know what order to put it in? Like, where does it say?
My formula right there?
Oh.
Is that what you needed to see?
Yeah.
Okay. All right, I don't need that. It's kind of bothering me. I can't do that in my calculator because of the variable, right? How do I get variables back on the ground? What do I have to have? I have to have a logarithm, right?
Yeah.
Okay, I've got to have a logarithm. So if I take the logarithm of this side, I have to take the logarithm of the other side. Should have written that the other way. Now can this guy move down and become a coefficient? Equals negative 0.078t ln of e. Addison, following up with you. What do we know about that ln of e? It's gone. Yep, it's 1. We don't need it there. Now does this calculator work? So ln of 0.5 divided by. All right, ln of 0.5 divided by negative 0.078. And round to the nearest what does it say? Hundredth. 8 point. Per day, so that would be days. Okay, last one. Similar, we'll use the same formula over there. Let's make sure we pay attention to how they're in the beginning and after time things work. The number of bacteria in a certain population increases exponentially, continuously with a growth rate. So my growth rate is 2.5%. How many hours does it take? I'm still looking for time. I don't know. So that means I need to know my y, and I need to know my y sub naught, my initial amount. So this time it says how many hours does it take for it to double? If it doesn't give us an amount, how much do you assume you had in the beginning? Yep, all of it, 100%. So after it doubles, how much would we have? 200%. Or 2, or 1. So now we've got 2 equals 1 e raised to the 0.025 t. ln of both sides? And then what are we going to do? Move that exponent. And now I have ln of e, which cancel, calculator work, ln of 2 divided by 0.025. T is 27.73 hours in this case. What if it tells you what? Before or after time? Then what are you solving for, the rate?
What do you have a different? How would you set that one up?
So show me what you've got. Is it continuous growth?
Yes.
Okay, give me your information.
It's fixed. So initially, and then after 5 years, it was 3,841.
So this is our y sub naught, and this is our y, and then our t is 5.
So we just write it as 3,000 equals 3,000.
So I like that you're asking this, because, so now we've got our e, we're solving for our k. I'm gonna put the 5 in there, because we like to see our number in front of. So what I would do is divide both sides by 3,000 first. I don't know what you get there. But then how do I get that exponent back on the ground? So we've got 3841 divided by 3,000. We're going to end up taking the ln of both sides. So 5k ln of e. Good from there? Super duper.
It was just like ln means something.
It does mean something. What does it mean?
I just